Right now, you are sitting perfectly still. You don't feel the slightest tremor, yet you are riding the surface of a planet spinning at over 1,000 miles per hour at its equator. If someone were standing in the extreme high latitudes, say deep in the Arctic ice, they might be one of the few humans positioned to survive what happens next. They would experience a single specific heartbeat where the Earth's rotation suddenly halted. In that fraction of a second, the physical world would seem to break. The horizon would violently tilt, and the sky would blur into a smear of motion as the ground beneath them locked completely into place. Under Newton's first law, an object in motion stays in motion. While the planet's crust hits a sudden, absolute break, everything resting upon it maintains its previous velocity. At the equator, this translates to a speed of 1,600 kilometers per hour. Anything not anchored deep into solid bedrock, trees, topsoil, and buildings, continues moving eastward at that exact speed. This 1-second halt isn't a simple pause. It is the instant conversion of our daily velocity into a mechanical force that shears infrastructure from the bedrock, pulverizing cities before the first second even ends. The atmosphere possesses mass and volume, which means it cannot stop as fast as the crust. It continues its eastward rush at over 1,000 miles per hour, resulting in supersonic windstorms that scour the globe. A 1,000 mile per hour wall of air exerts a destructive force far exceeding a nuclear detonation. It shreds the very soil straight off the tectonic plates, turning the atmosphere into a grinding storm of debris and fire. This cross-section illustrates a delicate balancing act. Centrifugal force holds a massive bulge of ocean water at the equator. Without the spin, that outward pull vanishes and gravity takes over. The equatorial ocean splits, creating 30-kilometer high walls of water rushing toward the poles. Within minutes, this spatial displacement of the oceans reaches the northern latitudes. The skyscrapers of New York City are swallowed under miles of crushing, turbulent seawater. Tracing the massive wave's path eastward, the identical wall of displaced ocean impacts the British Isles, erasing London from the map entirely. Across the globe, Tokyo faces the exact same geographical eradication as the Pacific Ocean rushes outward from its former equatorial center. The planet's essential fluids, the air and the water required for biology to exist, transform into a mechanical wave of destruction, sweeping outward to the extreme edges of the globe. This cutaway of the planet reveals what happens in the hours following the halt. Deep underground, the dense liquid outer core retains its massive kinetic energy. It sloshes violently against the now stationary inner mantle. This massive internal friction generates intense heat and pressure. The crust buckles under the strain, triggering global earthquakes and volcanic eruptions on every continent. This animation displays the Earth's magnetic field, which is generated by that swirling liquid iron, a system called the geodynamo. The sudden internal disruption breaks the dynamo. Our magnetic shield stutters and fails. Without that shield, the surface and any thin remnants of the atmosphere are instantly exposed to raw, deadly solar radiation pouring in from the sun. Once the geodynamo fails, the magnetic shield dissipates. Even if one survives the wind and water, the planet no longer possesses the means to deflect high-energy particles from the sun. Then the chronological endpoint is reached. The single second passes. The kinetic shockwave settles, and the Earth abruptly resumes its normal rotation. The planet spins once again, but the world resting on it is gone. We return to the lone survivor in the high latitudes, struggling to exist in a flooded, irradiated wasteland. They watch a broken, hazy sun rise over a completely silent, flattened horizon, entirely devoid of human infrastructure. Our cities, our history, and our absolute safety are not guaranteed. They exist entirely at the mercy of the cosmos. All it takes is one interrupted second to show us how delicate our physical momentum truly is.